Good morning, sixth grade. Here is today's lesson. This week, I will cover statistics. It will be a very quick, broad overview. So I've split it up into part 1 and part 2. Table of contents. 1. Math quote. 2. What this topic is about. 3. Objectives. 4. Introduction. And 5. Your concept development. There is a difference between not knowing and not knowing yet. Shaila Tobias. One more time. There is a difference between not knowing and not knowing yet. What is this topic about? Statistics is about using data to answer questions. In statistics, you will use the following 4 steps in your work with data. 1. Pose a question that can be answered by data. We'll work on that today. 2. Determine a plan to collect the data. 3. Summarize the data with graphs and numerical summaries. 4. Answer the question posed in step 1 using the data and summaries. Here are your objectives. I will recognize if a question is statistical. I will analyze data to determine if it's categorical or numerical. I will display data in different ways, dot plot and histogram. There are different ways to use statistics. We can use it in business, in sports, in education, agriculture, and medical studies. It helps with quality control, predictive maintenance for equipment, and inventory management. In business, they use it for performance management, alternative scenarios, and data collection. In sports, they rate players, decides who gets cut from the team, decides who plays on which days, your salary, and your draft picks. And in education, they help with educational planning, reviewing the system, monitoring academic progress, and others. A statistical question is one that can be answered with data, and for which we anticipate that data will vary, meaning that it will change. So if I ask the question, how tall is your 6th grade math teacher? You want to know if this is a statistical question. You have to ask yourself 2 sub-questions. 1, can I collect data? And the answer is yes. You can ask your 6th grade math teacher how tall she is. I'm 5'7". Will the data vary? No. Therefore, this is not a statistical question. Each time you ask me, I will give you the same answer. Let's try another one. What is the number of minutes students spend getting ready for school? Is this a statistical question? Can we collect data? Yes. Will the data vary? Of course. Depending on which student I ask, I can get different number of minutes. So this is a statistical question. Number 3, who is my favorite movie star? Is this a statistical question? Can I collect data? Yes. Will the data vary? No. At least it shouldn't if they're your favorite movie star. So this is not a statistical question. And simply by asking those 2 questions, we can determine whether a question is a statistical question. So we now know how to recognize if a question is statistical. We use 2 types of data to answer statistical questions: numerical data and categorical data. Say we have 25 baseball cards with the player's picture and information on it. If we recorded the ages of each baseball player, we would have numerical data. Each value in a numerical data set is a number. If we recorded the team of the featured player for each of the 25 baseball cards, you would have categorical data since each value collected is a team name, not a number. You can think of it as categories, categorical. Some other examples of numerical data include height, number of pets, and minutes to get to school. And some other examples of categorical data include eye color, birth month, favorite subject. So now we've met the second part of our objectives. I will analyze data to determine if it's categorical or numerical. Displaying the data. So there are two ways to display data. We have the dot plot and we have a histogram. Let's begin with the dot plot. Robert, a sixth grader, usually goes to bed around 10 p.m. and gets up around 6 a.m. to get ready for school. That means he gets about 8 hours of sleep on a school night. He decided to investigate the statistical question, how many hours per night do sixth graders usually sleep when they have school the next day? Robert took a survey of 29 sixth graders and collected the following data to answer the question. So really quickly, ask yourself, is the data categorical or numerical? Correct, it's numerical because we want to know hours. How many hours, and that's a number, a typical sixth grader sleeps. Here is the data he collected. So, I create a dot plot by putting the numbers that commonly appear. 5, 6, 7, 8, 9, 10, 11, 12. The first number in my data set is a 7. So, I put a dot over 7. And to help me, I cross out that number. So I'm going to quickly get the rest of them done. And just to make sure, I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. I have 29 dots in my dot plot, which matches the 29 sixth graders. That is how you do a dot plot. So let's try a histogram. The basketball team at Roosevelt Middle School were selling baseball caps with their school logo to help buy new uniforms. To obtain the correct cap size, students had to measure the circumference, the distance around the head, of the adults who wanted to order a cap. The following data set represents the head circumferences in millimeters of the adults. So here are your data set, and the cap sizes come in extra small, small, medium, large, extra large, and extra, extra large. I'm going to pause here for a moment, and I want to ask you, is this numerical or categorical data? If you said categorical, you are correct, because ultimately we are trying to find the cap sizes. Yes, we do have numbers, but this is not the data we're focusing on. This is. So we're taking this data, interpreting it, and turning it into a size. So we look at each circumference that we collected, and we put it into a range. For example, extra small covers 510 millimeters to less than 530. So I would say 529, 529.5, 529.9. So I'm going to take the table and move it to a different page so it's a little bit cleaner. Here's our data set, and here's our table. So I have a tally for extra small for 513, a second tally for 525 because it's still less than 530. The next one is 531, so we're moving on to small. 533, 535, 542, 543, 546, 549. The next number in my data set is 551, which is greater than 550, so I move on to medium. 551, 552, 553, 554, 555, 560, 561, 563, 563, 563, 565, 565, 565, 568, 568, and now we move on to large, 571, 574, 577, 580, 583, 583, 584, 585. Now we move on to extra large, 591, 595, 598, and 603. The next value definitely goes over 610, so we're moving on to extra, extra large, 612 and 618. So now that we've tallied how much of each range we have, we can just write a number to represent that frequency. So extra small, 2. Small, 7. Medium, 14. Large, 8. Extra large, 4. Extra, extra large, 2. All right, let's take our table and now really put it into a histogram, which is a fancy name for a bar graph. So I label my axes with my categories or my categorical data: extra small, small, medium, large, and extra, extra large. And I draw a bar up until the number that shows the frequency. So 2, 7, 14, 8, 4, 2. In 7th and 8th grade, you'll be presented with more statistics, in which case we'll use histograms to draw bell curves. You see how it kind of forms a curve? So that's what they use histograms for. But at the moment, our only concern in 6th grade is to be able to draw them and read the data from them. So now, can we display data in different ways? For example, dot plots and histograms. We sure can. That finalizes today's lesson. If you have questions, please log on to office hours. See you soon.